This is the story of X-ray pioneer and forgotten inventor Thomas Burton Kinrade from Jamaica Plain, Massachusetts. Kinrade built a 25-room mansion known as Ravenscroft, and in 2005 my wife and I had the opportunity of visiting this home in hopes of finding artifacts from this time period. After entering the home, we asked to see the basement first, and were led down some stairs to a solid mahogany ballroom, the entrance of which was a hidden door, a trap door inside a small room that contained a safe. The ballroom was lined in solid mahogany, and there were remnants from Kinrade's time period, including animals that he hunted, that were still on the walls. After leaving the impressive ballroom, we entered the basement, which had some utility rooms, an oil furnace, and a peculiar closet off to the side. I had asked to look in the closet, and when I opened the door, I realized it was not a small room, but a series of passages that circled the bottom of the house. They were blasted out of rock and had dirt and leaves on the floor. There was no electric lighting. We had to rely on the flash of our camera and flashlights to be able to see. Inside the rooms were artifacts from Kinrade's laboratory. We read about these over 10 years prior in Frederick Finch Strong's book, High Frequency Currents. In these rooms is where Kinrade made the initial X-rays, the most powerful generated up until that time. He was using a modified high-frequency coil of his own design, known as the Kinrade coil. We also found crates of glass plate negatives, 8 by 10 and 11 by 14 inches. On these plates were photographs of electrical discharges. These discharges were often described in Tesla lectures, but never photographed. Kinrade made a hobby of this and made hundreds upon hundreds of studies of electrical discharges, sparks, phenomena, and forms. He had named the positive discharges feliciform and the negative plumus, and also pointed out various comets and entities relating to electrical discharges. His most famous photographs were of the electrical entity, which showed positive and negative electricity united back to back. As we continued to explore, we found whiskey barrels, jigs, and wooden fixtures, lamp fixtures made by Kinrade, and a box containing beeswax, rosin, and coils wrapped in newspaper from Christmas Eve, 1898. These coils were wound with special triple and quadruple silk-covered wire. They were insulated in beeswax and rosin. They were sandwiched between glass rods tied in silk and matched Kinrade's patents from the late 1800s. We also found some capacitors used in his experiments, various dischargers, the remains of a 10-inch induction coil that had been disassembled, and rarest of all was a hybrid high-frequency induction coil from 1897. It was this coil that he made the world's most powerful X-rays up until that time. We found a 14-inch pancake coil that he used to balance his glass negatives to make photos, and a Victorian toilet tank, an oak box lined with copper, which contained the hybrid high-frequency induction coil. In the last room, there were concreted off sections and a peculiar trap door that led about 20 feet down. We couldn't find any other rooms below us, or at least any access points, but we believe this is where Kinrade demonstrated the original Keeley motor after Keeley had passed away. We also found glass plate negatives showing the plain evidences of fraud found once the Keeley motor was disassembled. Before leaving Ravenscroft, we were shown to the roof, where we saw a view overlooking Boston. We visited the Kinrade home again in 2007, and it wasn't until 2010 that we got an unexpected call to return to Boston, after Cheryl and Travis, two urban explorers, found an original Kinrade coil. To enter this building that had been abandoned more than 50 years, we had to find an electrical room with conduit that run through a 2-foot wide shaft into the basement of the school. Crawling through this shaft, we come up through the basement and found over 6 floors of abandoned equipment, and floors that had collapsed in upon themselves from years of neglect. It was in the attic of this school that the Kinrade coil was found. Accompanying us on this adventure was Rebecca Kinrade and her husband Toby, and they're now the proud owners of the original Kinrade coil, which is in all likelihood the oldest X-ray machine in the United States and the oldest complete surviving Tesla coil or high-frequency coil. Before we get into the construction of the Kinrade coil, it would do well to describe why it came about. And this holds true of why the Tesla coil or the Thomson coil or any high-frequency coil come about. In this time period, after the discovery of the X-ray, there were very few ways of generating high voltage. One way to produce X-rays powerful enough was with a large static machine. Now this is a 24-plate static machine, 7 foot tall, 6 foot across, and 4 foot deep. Another option was the induction coil, or the Ritchie coil. This is Ritchie's 12th coil from 1868. It has a hand interrupter and contains 68,000 feet of wire in the secondary. Right after the Civil War, it cost $257. Like Tesla, Kinrade started his high-frequency experiments using modified forms of induction coils. However, due to burnouts, he then began to develop his well-known Kinrade coil, and this contained only 2 secondary coils connected in series with each other, and 2 concentric primaries also connected in series. This allowed the highest potential to be in an area of least resistance. The power transformer used in the Kinrade coil is extremely unique. It's the lowest voltage of any commercial Tesla coil ever made. The primary was 104 volts and it was wound in 2 sections, and the secondary, also wound in 2 sections, provided only 900 volts to charge the capacitor. The transformer is unique, and it's one of the first AC transformers ever made or mass-produced. It has a core of fine iron wires, identical to an induction coil, and to make it a closed-circuit transformer, thin steel laminations were bolted to the ends of these fine iron wires. The transformer at full power consumed 200 watts from the wall. One of the most unusual features of the Kinrade coil is the water-cooled spark gap. This was a true quenched gap designed some 6 years before the famous Telefunken gap in Germany. The gap consists of a small brass table onto which the bottom spark gap segment is placed, which is a copper disc just under 6 inches in diameter. A lever can be swung forward or reverse that raises the copper segment up or down several thousandths of an inch. The upper contact of the spark gap is a 6-inch plate that's placed on 3 delta posts 120 degrees apart around the bottom plate. By adjusting these 3 points of the plane, exact parallelism of the upper and lower contacts can be made. To keep the gap cool, a jug of water is placed on the upper segment. This forms, in a sense, a self-recuperative condenser, as called out in Tesla's lectures. Even though the transformer is 900 volts, the spark dances along the surface of the plates, even though they're only 10 or 15 thousandths of an inch apart, and makes a beautiful spark gap. The Kinrade coil itself is contained in a hard rubber molding. This was one of the most expensive pieces of the apparatus back at the turn of the century. This molding conforms to the electrical requirements of the coil, having the most insulation in the middle where the voltage is the highest. The Kinrade coil was filed in 1897, patented 1898, and it matches the original prototypes we found at Ravenscroft. Unfortunately, the original Kinrade coils were burned out. It appears the machine was left unattended for a long period of time while it was energized. As a result, we had to rewind both secondary coils. Each secondary has around 1,000 turns of wire when completed. After winding the coils, it's time to now test them on low power. We're testing them here with about 50 watts of power to the main transformer. Before placing the coils in their original molds, one of the molds had to be restored. It had been cracked over time, and it was recast with a black insulating resin. Now both coil forms are ready to receive the coils. Before the coils could be cast, I had to turn on a lathe the two upright posts that connected the innermost turns of the coil with the electrode socket at the top of the Kinrade coil molds. I also had to do some torch work to form some glass rods that are used as insulating supports on the inside molds of the Kinrade coil. This allowed the coils to be placed in and hot wax to be cast around without having the coils themselves distort and deform. Small hard rubber posts also had to be turned in order to insulate the outermost turns of the pancakes. Here we're melting beeswax and violin rosin in equal parts. This is one of the best electrical insulations known today, and it's been used since the 1700s. We have Tesla coils 100 years old that still function fine using this wonderful insulation. Here are the molds cast and waiting to harden. And hours later, we have a finished Kinrade coil. It's now time to polish the molds and start testing again. During this video, the coil's consuming only 90 watts of power. For historical reference, here are scale models of 3 of the earliest manufactured Tesla coils. A 6-inch diameter spark gap, a half microfarad condenser, a 900 volt transformer, and a pair of low-frequency pancake coils may seem far from what a usual Tesla coil is by today's standards, but the Kinrade coil represented one of the most efficient high-frequency coils ever designed, and the concepts can still be used today to produce X-rays of enormous power. The machine is also useful for studying electric discharges, and is one of the few machines that can produce a variety of discharges unlike most cylindrical Tesla coils. Over the last 10 years, I've wound more than 100 pancake coils, and have studied the researches of Tesla and Kinrade, replicating many of their experiments and witnessing the sparks seen in the following photos. These sparks can only be seen to be appreciated, and hopefully future generations of Tesla coilers and enthusiasts might look to the past to rediscover some of these magnificent discharges.